Okay, guys, we're going to continue with our next presentation. We have David Grice with Nailing Container Security in Highly Regulated Industries. If you can all give him a welcome applause, guys.
Thank you very much. Hi everyone, my name's Dave. I work at ANZ. My role is a security partner. Probably the best way to frame that would be think of a security architect, think of DevSecOps, and the sliding scale that is in between those two. So that's the world I'm living in at the moment. I'm working with a team that are actually putting out some of this container-based workload into production. So I'm speaking not only from a theoretical perspective, but also have some practical application of this. And if you really like motorbikes, I'm also the man to talk about it. All right, starting out with an overview so we're all on the same page. Hands up, who's running containers in your environment? Okay, cool. How much? Put your hands up if you will be running more containers in the next 12 months. Yeah, okay. So it's definitely a growing trend. Hands up if you really like audience participation. No? Yes? Yay! All right. So Docker was version 1 in 2014. And you can read as much tech media as you want, but roughly the numbers I see are about 35% compound annual growth rate. So this thing's flying, right? Kubernetes, which we'll touch on as well, went version 1 in 2015. So that's the orchestration layer. And tech media have been calling 2019 Kubernetes the year of the enterprise. So, and there's some compelling reasons why you'd want to do this. You get platform independence, you get resource efficiency and density, you get, when implemented correctly, effective isolation, you get speed, scaling, smooth scaling, and key for a lot of us will be developer productivity and integration into development pipelines. So it's understandable that our app teams are coming to us and saying, we want to run containers. And let's be honest, cloud VMs weren't really, cutting it for a lot of dev teams. They really want to get onto this next iteration of technology. And aren't they beautiful? Like I look at containers and I think, that's lovely. I want all containers to look like that. But they don't. So we were given the challenge in security of going, well, how can we secure these things? It became abundantly apparent to me that the tools we have today to manage on-prem infrastructure are not going to be the tools we need in our arsenal to secure cloud-native computing. So, put your hands up again if you roughly have a handle on what intrusion detection, vuln scanning, and AV is. Good, most of us. Excellent. Now, let me ask you this. If you were asked to run AppArmor, install an instance of Claire, and then integrate Notary into your CI/CD pipeline, how many of you would feel the same level of confidence? Exactly, no one. It's very different tooling. So, tooling's changing, and we as an industry also need to change. Also, this stuff's being built in code, so securing the pipeline all of a sudden doesn't become a nice to have, it's a need to have. One other observation I'm seeing as well is we're seeing a significant shift in control ownership. So I have an app team, I have a network team. App team needs internet access for their application. They go to the network team and request a firewall rule. Well, guess what? Infrastructure is now code. That's just one team operating that control. You no longer have this segregation of duties. So auditors are freaking out a bit as well. And we've also then got the challenge of the fact that containerized workload is ephemeral, it's moving up and down. So, we get 2 days is the average lifespan of a container. So how does a highly regulated financial institution such as ours manage all of the forensics requirements on that workload that's coming and going? So I'll just go through a typical anatomy of what a container stack looks like. Spoiler alert, there's not a lot new at the physical server layer, other than it might be hosted by Amazon, Google, or Microsoft. Host OS, you've still got your typical Linux kernels. This is where it gets a bit interesting. So you've got your namespaces, C groups, and security. And the reason I call these out is namespace is that essential container component that we're talking about when we talk about containers. Namespace is that real isolation boundary. C groups provide control over the resources that those namespaces consume, CPU, memory, I/O, etc. And security is the mandatory access control, things like AppArmor and SE Linux, which we're also going to talk more about. Sitting on top of that is your Docker engine. Now, Docker's cool. It's a client-server app. It has a daemon, which is your dockerd command. It has a CLI that you can interface with, and it also has a REST API interface. And then in comes your applications that you bring along with it. So you bundle in application, binaries and libraries you need that aren't in the underlying host OS. Now, at this point, you might be realizing that doesn't look like a traditional VM architecture where I've got a very tight definition and boundary between the underlying hypervisor layer and the application running on it. The application is sharing the underlying kernel resources. Don't let that point escape you as you work through this talk, because it's a very key component to why we need to have multiple layers of defense. And then on top of all that is Kubernetes. Now, I've chosen Kubernetes because I think it's going to win the race in terms of orchestration, but there are other technologies out there. And what Kubernetes is doing is it's bringing together the orchestration, spinning up, spinning down, starting, stopping, grouping things into clusters across multiple hosts. So if you've got, you want to run a highly resilient application across multiple data centers, you would use something like Kubernetes to do that. So that host OS, we're going to talk about more as well, because it's important that it's not just the same like a generic Linux host OS. Now, our anatomy from within Kubernetes. So if we're looking Kubernetes top down, you get these new naming standards of things that may not mean much yet. So what you've got is a container. That's the innermost component that sits inside a pod, that shares a namespace, that sits in a node, that sits in a cluster, that sits in a project. Now that project would be an Amazon account if it was done in Amazon. This is taken from the Google blog. I think the two things you need to know here are containers themselves do not provide enough isolation on their own. They need more, and I'm quoting Google when I say that, who invented a lot of this stuff, or really was the first to use this in anger. And I think each boundary here now becomes an opportunity to do security right or wrong. And the risks are real. This is my fear, uncertainty, and doubt page, FUD. I won't dwell on it. We all know how to explain this, but it's a Linux kernel at the end of the day. You inherit a lot of the lovely Linux kernel vulnerabilities. And publicly, people of using this have got themselves caught in a bit of a mess. Tesla, Weight Watchers, and Aviva. The good news with those ones are that, well, good news. What got them was misconfiguration of implementation, not necessarily zero-day vulnerabilities with a Kubernetes environment or a Docker environment. And the defaults have changed since early versions of this technology, and they're rapidly changing. So now that a lot of the same things wouldn't be affecting your organization if you were to deploy a new instance of Kubernetes and a containerized workload tomorrow. But the bell has been rung and can no longer be unrung. So the bell was rung in December 2018 when we saw the first API auth server bypass. Thankfully, that was responsibly disclosed by and identified by a contributor to the Kubernetes project. Run C in February this year was a container host breakout from host to root. So this is the worrying thing that we've always worried about with hypervisors of a guest to host breakout. The exact thing we were worried about in containers happened and was disclosed in February 2019. The good news is as well, I'm going to tell you how that wasn't a problem for us in the way we've configured our workload because of some of the settings in the Kubernetes stack. So that harmless little request from application teams to go, Dave, we want to run containers, help us to do it safely, has become now a complete audit of these 7 items. So the underlying CI/CD pipeline, underlying OS security, container image runtime security, orchestrations, network logging and auditing. Now, none of that's new, but it's also all new because it's being done in the context of a container. So some of the approaches and the way we've solved these problems traditionally now need to be revisited. So at this point, let's just pause and consider what we know. We've got vastly, maturing technology, but critically one that's not yet mature. We've got technology that's unfamiliar for a lot of security teams. We've got evidence that the risks are real. And we've got statements from Google on their blog that containers are not enough isolation on their own. And yet, despite all that, we've got an insatiable adoption rate for this technology. So we probably should be a little concerned. But just like containers allow you to segment portions of your application and break your problems down, we can break our security problems down as well. All right, so this is the meat and potatoes of the talk. I was inspired by a talk I saw here a few years ago that just went into quite a lot of depth. So I'm going to fly through these slides, but it's important, we'll go through some questions at the end if you've got any. So starting off, the build environment. What are our problems we're trying to solve? Well, we've got malicious or suboptimal source code, alterations to our build policies, config scripts with errors or ones that expose credentials, supply chain provenance, insecure libraries, and down revisions of existing code. Now, at this point, you're thinking, oh, David, you're going to go into war and peace about telling us to do how things we already know? Well, kind of, and also the other thing you're thinking is you really like bullet points, and yes, I do. Bullet points everywhere. I won't spend a lot of time because hopefully you know how to solve your source code and securing your build pipeline, but we'll just fly through this. Protect your environment like your app. Have governance over your code changes. Principles of least privilege apply here most importantly. So who has access to your code? Who has access to deploy? And when we talk about protections, have 2FA turned on major administrative activities in your source code and build pipelines. So I think that's a key, 2FA is key here. The other thing is, as you start to get more savvy in the way you build your code, you can start shifting left, and a buzzword, but shifting left with your IDE as well. So you've actually got plugins that sit in the IDE that are identifying any source code vulnerabilities as code's being cut. That's a great thing because they will then integrate with your SAST tooling nicely. So if you've got a SAST tool, static analysis tool, they often have an IDE plugin that you can use. So do that. You also want to implement policies to prevent bad code. So it's great that you found some bad code. Are you still letting that bad code out to production? So just have a think about that. And have a pattern of pre-agreed safe libraries. Hashing your binaries is pretty good as well. Is this the code I'm expecting? And so rather than more talking, this is a picture of kind of what it could look like if it was all hanging together. On the left, you've got your source code, Dockerfile, test code, all going into your Git repo. Hopefully you've got your IDE plugin checking as it's going in. You then kick off a code scan from your Git. That's your SAST tooling. You then might want to have a security unit test. So what's a security unit test? They are kind of mini tests to detect cross-site scripting or SQL injection without having to build your full app. You can just build parts of your app and run these tests against it. And then the composition analysis. So in today's modern apps, we're building so much code from other people's code, but all that code you've imported into your app safe and secure? Composition analysis will allow us to go and work out that, we're using some vulnerable open source library, better go fix that. As you push and pull stuff through your registry and your building, you want to use slave accounts. So it's again, principle of least privilege. You then want some sort of validation check that yes, this is the container I'm expecting, and a go, no-go stage gate before you go into prod. All right, host. The underlying host operating system. So what are we worried about? Same things we worried about now, underlying kernel vulns, but we get the benefit that containers are sharing these operating system resources, so yay. So we also want to quarantine containers from each other. And we also want to stop any container breakout. So again, that's the guest to host breakout in a traditional VM environment. So how do we stop that? Patch often. This is where containers get really cool. You do not have to wait like you have to patch a hypervisor to take down a whole set of infrastructure. You can just patch this stuff. So patching your underlying host actually is a lot easier in container workload because stuff can spin up and spin down. So that's cool. You want to run a specific container OS though, and the reason you do that is because it forces you to only run containers in that workload, so that you don't end up basically putting things in the wrong places, and the attack surface for attackers is very small. gvisor. So we're going to talk a lot about how do you protect the containers that are living in user land, but how do you protect the kernel itself from any malicious attacks? So gvisor is a great open source tool that is freely available. It essentially sandboxes the calls between the containers down to the underlying kernel, and only lets safe code go through. So it's a great little tool. You then also want to look at who's got access control on those underlying OSs. And then of course you can drop the ops altogether. Although we're highly regulated at ANZ, it doesn't preclude us from running workload in the cloud. That said, we've got infrastructure that does containerized workload both on-prem and in the cloud, so we've got the kind of best of both worlds. But you can use cloud tooling to manage that underlying OS as well. All right, so then we've got our container image. What's the problems there? Well, images need hardening. Defaults are not exhaustive, and then provenance over supply chain. I'm probably missing one there actually, and that is, where are you getting your images from? Is it Docker Community Hub? So how do we solve those problems? Well, most of you would have heard the CIS benchmarks. If you haven't, get onto it, it's great. However, CIS benchmarks, what they do is they tell you how you should harden your images, how you should harden your use of technology. Docker Bench security is a bit of a hand-in-glove relationship in that regard. What Docker Bench is doing is it's taking the CIS benchmarks and running it against your workload and giving you an output. So you can actually build that into your pipeline and go, do not pass go to prod unless you pass the CIS benchmarks hardening standard. So Notary does a lot of the container signing and chain of custody, so it allows you to go, is this the container I'm expecting as it goes through your supply chain? Make it hard for attackers, right? Remove unneeded modules and packages so they can't live off the land. Do you need SSH in your containerized workload? I would argue you don't. And you may want to leave it hanging around in dev, but you certainly don't need it in prod. So get it off your environment. If you're going to make a change, you go back to your build pipeline and you build it again. You can do your apt-get updates as you're building, so you're not running around with stale images. And the next problem you've got to solve is runtime security. Now, I won't pretend to go into this in detail. You can all go read the MITRE attack framework in your spare time if you want. But they're the things we're worried about. They're the things we've always been worried about. But we need to solve them in a different way in our containerized workloads. So the first thing really we want to talk about here is mandatory access control. So AppArmor or SE Linux, you may have heard of those technologies. They've been around for actually ages, but they've never been really able to be implemented with anger until, I would argue, now. Because a traditional bloated operating system would have too many moving parts that you could never just whitelist only run this. It wasn't as easy back then. Now we're putting our applications into microservices. So each application is broken down into very defined chunks, and those very defined chunks can have very defined whitelist rules around them. So this technology is now having a bit of a resurgence, and there's some great open source stuff from a guy who's Aussie guy on the OWASP chapter. His name's Osama El Naga, and he's got RCE Guard as well as is a great tool to help make this process easier. You want to also separate process ID namespaces per tenant so they're not shared. Now, if you're running Kubernetes, this is by default, but If you're not and you're just running a Docker instance, be mindful of that. We talked about SSH earlier, and why maybe you store your state somewhere else so your containers can run in a non-persistent and read-only mode. Docker itself has a seccomp profile that you want to turn on. Just running it in default is fine. It blocks a lot of nasty stuff. Those nasty stuff are things like add key, key control, request key, clone, unshare. Those are the things you want to typically stop. And if you go back to that fear, uncertainty, and doubt page with all the vulnerabilities and exploits, those are the words you keep seeing appear as well. So Docker seccomp profile, turn it on. Default's good. It is now anyway. It wasn't always, but it is good now. Enforce some time to live thresholds. So how often do you want to rebuild your workload? Given vulnerabilities are coming out every day, and given your pipeline does a vuln scan as it goes, maybe you only need this stuff. Live for 7 days and then you rebuild it. And then continue to vuln scan against running instances as well. So don't just think, oh, I vuln scan during my build, job done. I think you need to keep scanning as you go through runtime. All right, now orchestration. This is Kubernetes. This is a big area where we want to talk about because it's a lot of opportunity here for attackers. So what are we worried about? Well, we're worried about stealing secrets, service account accesses to the API layer, metadata APIs in your cloud providers. So if you're in Amazon and you go to 169.254.blah, you're going to get a very awesome, if you're an attacker, list of running workload. And so it just is easy to enumerate your running workload. Now, although that's nothing to do with containers, you're trying to make it hard for them. So we've got to look at addressing that. And that's an attack vector that is in use in the wild right now. We've got enumeration that's coming from that. We've got the token replays. We've got man in the middle. We've got container breakouts, etc., etc. So again, just like Docker had the CIS benchmarks and Docker bench security, Kubernetes has got the same. CIS benchmarks for Kubernetes, Kubernetes bench security. Use them, they're awesome. More recent versions of Kubernetes introduced this concept of RBAC and cluster role binding. Hasn't always been the case, but now the more recent versions do have this, and even more recent versions have now moved to a state where no privileges are granted by default. You have to invoke them, which is also good. You want to disable the mounting of any service account tokens. You want to restrict access to the Kubernetes API. Not every pod in your Kubernetes workload needs access to the Kubernetes API, so restrict it where you can. Enable pod security policies. This is a big one. If you do one thing today, do that. So the run C vulnerability that I talked about before wasn't a problem for us because we had pod security policy turned on to run as non-root. So any workload that was running in our Kubernetes stack was not given root privilege. So the ability to then break out to host wasn't an option in that run C scenario. Now, the Tesla Weight Watchers one that got compromised earlier, they got compromised because the web UI dashboard was on. By default, it's no longer on. And I would argue if you're doing this in the cloud, you probably don't even need it at all, because a lot of the telemetry you would get from that service is going to be provided by your console you see in your cloud provider's service. Also, implement a network policy using pod labels. So this is layer 4 networking, but of course it's not IP addresses anymore, it's tags. But do essentially something akin to a layer 4 network policy that only pod A can talk to pod B, but they can't talk to pod C. Encrypting your Kubernetes secrets. So your Etsy shadow file in your master node that's managed by your cloud provider, they may solve this for you. I know Google, who I'm more familiar with, do this, but a default instance of Kubernetes does not. So just be mindful of that. Restrict your kubelet permissions so you can only see the pods that are on each node. So should a pod get compromised, it's making it harder to reach out and laterally move for an attacker. Istio service mesh, we're going to talk about this. But essentially layer 7 controls as well. add a proxy around that metadata for the API. You want to log everything outside the cluster, because guess what? Attacker gets on box, attacker turns off logs, make it hard for them, log outside the cluster. Rotate your certificates, and as I said, the latest and greatest version is 1.3, but is version 1.13, but version 1.8 is the real milestone version where a lot of these feature sets changed to very sane and security sensible defaults. And so this picture is, just to avoid you watching more bullet points go past your eyes, and just to really talk about the difference between self-managed and cloud-managed. So on the left, obviously, that whole stack's your responsibility if you're running it yourself. If you're running it in the cloud, you generally would consume a service provider's offering, and so they manage the master node and the etcd, which is nice of them. But some of the security settings you want to invoke depend on the underlying version that's being provided. So just understand that distinction. If you're trying to turn on pod security policies and you're trying to turn on your Docker seccomp profile and things like that, you kind of need to understand the versions of the stuff that's running underneath the hood as well. So just watch that. And obviously, if you're keeping it current and you're keeping it fresh, these problems go away. Networking security is next. Now, you might argue that there's more surface area because you've essentially got, rather than one big monolith application, you've got all these distributed services, and so you can get in the middle of that traffic, and there's more surface area. We also want to isolate discrete workloads and restrict traffic to unintended services. We really, really want to prevent egress to the internet unless it's intended, and then we also want to, and here's one, okay, so you were meant to have, hard isolation between our demilitarized zone and our trusted workload. So unauthed workload in the DMZ, auth workload in behind the scenes. But guess what? One master. The Kubernetes that's serving the DMZ is also the Kubernetes API that's serving the trusted workload. If one gets comped, how do you prevent the other side, the trusted workload, getting compromised? Istio is going to help us with that. So concepts are largely the same in that it is network security. So although we might use tags rather than IP addresses, the same concepts largely apply. Using an Istio service mesh over the top of your layer 4 networking is a really, really good idea. And I'll explain why. So imagine this scenario, right? You've got Kubernetes operating at layer 4. And the Calico plugin is what's doing that network policy that says pod A can talk to pod B, but not talk to pod C. But given the Kubernetes is also what's hosting the workload, it's feasible to think that if a pod got compromised and someone got root on a pod and someone could expose that Kubernetes API, they could break down that layer 4 control. So in comes Istio, and over the top is a layer 7 mutual TLS proxy that will essentially inject the same rules. A can talk to B, but not to C. But it will also take that traffic and encrypt it as it flows through, and it's a separate control plane in reinforcing it. So if Kubernetes got compromised, you've got Istio reinforcing that over the top. And so you get something akin to two-factor auth on your network traffic. You must come from the right layer 4 IP address or network tag, and you must have the right Kubernetes cryptographic secrets in order for you to talk. And it's when you get both of those in concert with each other, you really start to see why actually it's possible that we could be more secure using this sort of technology than less. We can't escape the fact, though, that a lot of people are going to do this in a cloud environment, and so we all know that we can get ourselves tripped up and self-harm with misconfigured S3 buckets and the like. So good practice here is obviously to harden your cloud accounts. The key takeaways are, separate your accounts or resources or VPCs, avoid the 5 0-sider ranges, limit privilege, and maybe introduce a segregation of duties. So inbound and outbound IP address changes have to come from your cloud services team. The app team that's running the workload has to do a separate ticket to request that. Also, run regular checks back against your workload to confirm you're running in a known good state. Don't just assume that because my Terraform script is built perfectly, that someone hasn't actually gone into the dev environment and done some mucking around and have compromised the config. Go and run those checks against what known good looks like. And, key tenets are log and limit your blast radius. So just a bit on logging. We're very close to the end, so, we're getting there. You want to meet your operational requirements, so that's important. You also want to make sure, though, that, we've got to be careful that the application logging on its own is not enough. We've got layers of the stack we need to think of now. We've got the app, we've got Kubernetes, we've got the cloud infrastructure. If you're running in the cloud, there's a lot of stuff to consider now. So logging needs to consider that. Also the fact that this stuff's moving around and transient. And then you've got the forensic requirements. A pod's been compromised, what was running at the time. And then, because of all that, you've got to then worry about signal to noise ratio. So how do we solve these problems? Small and simple. If you've got a small application, maybe just consider a dedicated logging container. If you've got a big and complex one, you might want to consider a sidecar approach. But just make sure you practice end-to-end logging. And don't forget that it all needs to go somewhere. The OWASP cheat sheet is great as a takeaway in terms of things you need to focus on. Try and log to a separate store under a dedicated cloud account. So don't make the cloud account where the workload's running the only account where your logs are kept. Sync it to another service account that's isolated. And then the big one is alert and alarm when logs don't arrive. That's often one that gets easily forgotten. I'd like to shout out to Sysdig Falco in terms of addressing the signal to noise ratio. So again, all the technologies I'm mentioning so far are all open source. But Sysdig Falco is a great one in terms of identifying the key ones you want to worry about in a signal to noise ratio. So, a shell is run in a container, or there's a there's a server process that's spawning child processes, or my LS is now making outbound connections. Like, what's that about? Sysdig will help you with that sort of stuff. And then just have processes to monitor change in your cloud services. All right, that's the bulk of the talk over and done with. So rather than, I think, expect everyone to implement all of that, there are some essential ingredients that I think make up a secure stack. And they are running a minimal operating system with no SSH. You don't need a big OS for your container and Docker images. They can be quite small. 400 meg would be a large one, in my opinion. You want a restrictive network policy, so that's layer 4. You want to obviously do all your cloud account hardening. You want to do your configuration assessments as you're going through your build pipeline. And when you're doing your Docker bench and kube bench securities, make sure your RBAC is set to principles of least privilege. You want to have a look at some runtime protection. There are some commercial solutions that are around that can help with that, and string a few of these controls together. You want to protect your build environment like your app. And then you want to do pod security policy run as non-root. So just to wrap up, the defaults are better now, haven't always been. You want to shift left. So if you're running a security function, you need to get down in the weeds with the DevOps teams that are running this stuff and help them. You might also be having to review and commit code yourself, and I'm sympathetic to a lot of security teams. They may not have the resources that do all that, so definitely something that we need to adapt into. And the other thing I haven't really talked about yet, is enforcement. So what we've talked about is the what. What do you need to do to secure your Kubernetes and container workload? The how you enforce that. There's some work happening at the moment with Open Policy Agent, and your cloud services will also have a range of organizational controls that you can set and enforce, and guardrails. There's probably another talk due by me actually on how you enforce some of this stuff. So, but just think about that. That's can't be ignored. And that is my talk. Thank you.
Excellent. Thank you very much, David. Running perfectly on time, so we have time for questions, as we do down the back.
Actually, I have two questions. Have you used Nomad, and what do you think of it?
No, I haven't used Nomad. What does Nomad do?
It's similar to Kubernetes in that it can run Dockers and stuff, and it can
Oh,
run
okay.
It's like it does its own orchestration. And
Yeah, okay. Listen, there's a few technologies, Mesos, Docker Swarm as well, that are spinning around, but I think we've chosen Kubernetes largely because of the fact that on-prem, there's some commercial offerings from Red Hat that were more appropriate for a highly regulated entity to run, and then we also wanted the best support from a cloud provider as well, so we've chosen Kubernetes for those reasons.
And the second question was, what vulnerability scanning did you use?
There are a number of choices. We've gone down a commercial path to string together a few controls. So we use a product called Twistlock to do the runtime protection, but it's also doing vulnerability scanning, and it's also doing config drift for us.
Any other questions? Okay, excellent. If you could all give David another round of applause.